Solubility of a gas in a liquid. The most commonly used form of Henry's law states that the partial pressure of the gas in vapor phase P is proportional to the mole fraction of the gas Xi in the solution and is expressed as P equals to Kh into Xi. Here Kh is the Henry's law constant. The graph shows observations when HCl is added in cyclohexane. On the y-axis, we have partial pressure of HCl in torr, and on the x-axis, we have mole fraction of HCl in its solution in cyclohexane. The graph is a straight line in accordance with the Henry's law. Application of Henry's law. The most common application is to increase the solubility of CO2 in soft drinks and soda water. The bottle is sealed under high pressure. Now when we open the cap of the bottle, the pressure of CO2 above the liquid decreases and the amount of CO2 dissolved also decreases. Now when we pour the cold drink in the glass, we can see the CO2 fizz in the glass. Text. Scuba divers must cope with high concentration of dissolved gases while breathing air at high pressure underwater. Increased pressure increases the solubility of atmospheric gases in blood. When the divers come towards surface, the pressure gradually decreases. This releases the dissolved gases and leads to the formation. Text. At high altitudes, the partial pressure of oxygen is less than that at the ground level. This leads to low concentrations of oxygen in the blood and tissues of people living at high altitudes or climbers. Low blood oxygen causes climbers to become weak and unable to think clearly, symptoms of a condition. We have two fishes living in a jar. Now their home is changed. First fish is placed in the same condition, while when the second fish is shifted to a higher temperature water jar, it dies. Oxygen dissolved in the water decreases with the rise in temperature. Therefore, fish dies due to lack of oxygen. Let us take an example on solubility. If N2 gas is bubbled through water at 293 Kelvin, how many millimoles of N2 gas would dissolve in 1 liter of water? Assume that N2 exerts a partial pressure of 0.987 bar. Given that Henry's law constant for N2 at 293 Kelvin is 76.48 kilobar. Solution. The solubility of gas is related to the mole fraction in aqueous solution. The mole fraction of the gas in the solution is calculated by applying Henry's law. Thus, Xi of nitrogen equals to P of nitrogen by K equals to 0.0987 bar by 76.48 kilobar equals to 1.29 into 10 to the power minus 5. As 1 liter of water contains 55.5 mole of it, therefore, if N represents number of moles of N2 in solution, Xi of nitrogen equals to N mole by N mole plus 55.5 mole equals to N by 55.5 equals to 1.29 into 10 to the power minus 5. N in denominator is neglected as it is very less than 55.5. Thus, N equals to 1.29 into 10 to the power minus 5 into 55.5 mole equals to 7.16 into 10 to the power minus 4 mole equals to 0.716 millimole.